Hey everyone, it's Jeremy Myostis from the NRCS, and in this segment we're going to be talking about building resilience with low-tech restoration. And before we get into some of the science behind that, I want to just provide a quick reminder of why we view resilience as a guiding outcome we should all be shooting for. Remember from day one, this shared vision we tried to instill in you of as we reconnect these floodplains, we actually improve that natural storage capacity of our soils that increases soil moisture, increases productivity, and enhances that resilience to drought, fire, and flooding that really affects many of the ecosystem services and values that we care about. And recall that Joe introduced you to principles of riverscape restoration, and I'll remind you of at least two here that are very relevant to this resiliency topic. The first being the critical role of structure in forcing that complexity and building resilience. And so Joe shared this example of a beaver complex that mediated the effects of wildfire in Idaho here. This Emerald Island was the last thing left standing in a sea of charred ash. And it was because the structural forcing of water across that valley bottom kept it wet. It turns out water doesn't burn. So here's an example of that increased productivity, increased resiliency to fire. And of course, that structure is also important in creating inefficiencies in our conveyance of water through the valley bottom, which is very healthy. It helps lower those peak flood flows, but also elevate our base flows later during the season. And a common response that we see from those changes is an increase in our riparian vegetation following restoration. And so in a typical post-restoration project where we're successful, we see this retraction of our upland species that have invaded the valley bottom floodplains, things like sagebrush depicted here in the red, and an increase in the green groceries, or those wetland and riparian obligate type plants that are a direct response of having more water in the system longer. And one thing we thought early on was, if we're doing this work at scales that matter and the signal's meaningful, we ought to be able to detect this from space. And the reason is we have this incredible archive of remote sensing data available to us. The Landsat satellites have been flying around taking pictures of the Earth's surface since 1984. And one of the critically important pieces of information we can derive from that is this index, or NDVI. You might have heard of that. It's called the Normalized Difference Vegetation Index. Essentially, it's a measure of greenness out there on the landscape. And in its simplest form, if you look at the picture here, low NDVI would be indicative of like our uplands, our dry uplands, whereas high NDVI could be our really wet and highly productive valley bottom areas. And so when we at NRCS started getting serious about scaling this work up, we actually went to my colleague Dave Noggle at the University of Montana, and he's our Working Lands for Wildlife Science advisor, enlisted his help and said, Dave, can you take a look at this question of quantifying resiliency and give us some confidence going forward that if we did this work, it'd produce the types of outcomes that we want. And normally he jokes that science is always chasing implementation, right? We're out there doing stuff really fast without not always the evidence that we'd like to have at the beginning. But in this case, because we have the satellite data archive, we're able to take a look back at other people's projects and quantify some of this stuff. And so Dave found a researcher, Nick Silverman, who led this study that several of us contributed to, where we essentially looked at 3 separate project areas across the West. And these projects were varied in how long they were on the ground, and also the types of structures, the low-tech work that was involved with each project. And so just a quick introduction to those. The first one I'll start with is in the Gunnison Basin of Colorado, where really diverse partnership rallied to address head cuts and gully erosion in their upper headwater wet meadow systems using those Z-dike rock structures that we talked about in the low-tech intro. And that project, when we did this study, was on the ground less than 5 years. The second project we looked at was the Bridge Creek project, which you've just learned about from Nick. Again, that was involving beaver dam analogs and mimicking that beaver dam activity, and then also enhancing natural beaver dam activity. And that was a kind of intermediate term project, about 9 years on the ground when we did this work. The final project was in Maggie Creek, Nevada, and that's a long-term project, been on the ground over 20 years, and it was really a story of private landowners, ranchers, and the Bureau of Land Management coming together to make changes to their grazing management systems, and not just exclude livestock, but actually change the time and timing, how long are the cattle in the riparian area, to induce riparian recovery, which then also set the table for an incredible reoccupation by beaver. So we'll take a look at this study that used NDVI to quantify changes in that productivity as an index of resiliency through time. And if you want more details on that, I'd encourage you to check out the paper cited here. Okay, but jumping right into the results from the Gunnison Basin of Colorado using those Z-dike structures. And we'll show you a series of charts that'll look similar. On the y-axis is NDVI, or productivity, that greenness index, and then plotted against time. And the gray bars represent precipitation. So you, just as a point of reference, can see how the system was changing through that period of time. And then the lines represent restoration versus control reaches. And what we see before restoration was implemented in 2012 in the Gunnison Basin, the restored reaches largely tracked controlled reaches. They bounced around a bit with precip, but largely were tracking one another through time. But following restoration, we see this departure, where our restored reaches are actually staying more productive than our control sites. And you can quantify that. It's actually about a 24% increase in productivity, or that natural storage and resiliency that we were talking about before. And the partners on the ground have these incredible photos documenting that change. They've also been doing line transects and measuring actual vegetation change in these areas, and they've seen upwards of 400 or 500% increases in wetland obligate species following restoration, which we're now able to pick up using satellites in space. The second project there in Bridge Creek, very similar patterns, right? It looks like the restored reaches are really tracking those control reaches through time prior to restoration. Following restoration, the restored areas depart and stay productive more regularly over time than the control areas, even though both fluctuate with precip still. And that turned out to be about a 20% increase in NDVI, or productivity, following restoration. And in our final example, the one that's been on the ground the longest, Maggie Creek, Nevada, We had to take a little different approach here because the project was done a long time ago and was a large project, so we didn't have a similar control stream to compare this to. And so we simply plotted through time. The red line is Maggie Creek, which the dotted line represents when restoration began, about 1994, and then again the precipitation through time. And if we actually analyze that, what we see is there's really been no change in precip through time, whereas NDVI productivity has been statistically significantly increasing through time. So we see the effects of restoration happening in this really large project area, and it continues to go up. Restored sites are not only more productive overall, they're staying greener longer during the summer, which is critically important in the West, where everything dries up, right? That August, September, October is really a crunch time when there aren't a lot of green groceries out there on the landscape. And we see that improvement in every one of these case study areas with, of course, Maggie Creek, a project that's been on the ground the longest, showing the greatest improvement from July to November, having more of that productive valley bottom vegetation on the landscape. And a really cool, innovative way of looking at resilience, Nick Silverman came up with this index of resiliency that essentially just measures how much does NDVI change with changes in precipitation. In other words, how sensitive is the vegetation to how much moisture we get. And what we see if we plot Maggie Creek through time is that in the early days following restoration, in the first 5 to 10 years, there was quite a bit of fluctuation. In other words, the amount of snow or rain that we got really dictated how much vegetation in that riparian area grew. But something changed after about 10 years following restoration. Productivity was no longer sensitive to precipitation. The valley bottom sponge had filled up. And so it really didn't matter how much moisture we got in that system. It stayed green, which is just an incredible finding for anybody who is concerned about, the fluctuations of climate, extreme drought that seems to be more frequent. This is a very exciting finding for the future of restoration, that maybe we can start to actually buffer these valley bottom systems against the effects of climate change and other things that are happening. If we plot the other projects, other case study areas along that same curve, boy, they're really tracking that pretty tightly. And so we're excited to kind of see how this plays out as they are on the ground longer, if they show a similar type of trajectory where they decouple essentially productivity from precipitation and just become more resilient. So what does this mean for working lands? Well, my friend John Griggs, who's the ranch manager out there at Maggie Creek, really says it best. So I'll just paraphrase one of his quotes he uses a lot when talking about this photo. He says, after years of prolonged drought, we have a place like this where there's plenty of water and green forage available for our cattle at a time when a lot of people around us are having to haul in water for their livestock. That's resilience. That's the kind of resilience we're talking about with low-tech restoration that's possible, that's not only important to the critters that we care about, but vitally important to the people that we work with that own and manage the land and survive, derive their income from the land. So to me, this is how I would start my conversation with producers. This is the common ground that I think we have and why they might want to participate in doing this type of work. Okay, so just to wrap up, There are some tools you can use. There's an increasing amount of accessibility to the remote sensing and NDVI data. I'd encourage you to check some of these resources out. One of them is our map.sagegrouseinitiative.com. If you go to the MESIC resources tab, you'll get a map like this that shows you where some of those valley bottom and other wet resources are across the landscape. But maybe of most interest is that you can actually do your own custom analysis. So you can draw in a polygon anywhere in that region, or you can drop in a shapefile for your project area and hit calculate, and it'll summarize NDVI for each of the pixels within that area of interest and provide you with a time series that looks like this. This is an actual project in Oregon. And you get a chart that shows you that productivity, that index of greenness through time from 1984 to 2016. And in this case, this project went in about 2004, and we see a dramatic difference between NDVI prior to restoration versus NDVI after restoration. These are the types of outcomes we want to be measuring. Think about the ability to report back to your funders or your landowners or all types of other folks who might want some kind of accountability for the work that we're doing. We can use these simple indices. They're blunt instruments, right? But boy, how powerful is that we can actually quantify it from space. So I'd encourage you to look into some of this. And again, thanks for joining.